Hello and welcome to this LangChain tutorial. So in this video, we'll discuss what are document loaders in LangChain, and we'll also go through some of the document loaders with code examples. So in order to understand document loaders, let's first set the stage with retrieval augmented generation RAG. So in generative AI, one of the important tasks is to create these RAG pipelines, right? So, and as the name itself suggests, retrieval augmented generation. It gets its name because it augments the generative capabilities of a language model by providing it with some external documents using external retrieval step. So if you are creating a RAG based chatbot for any specific company, then the documents or policies of that company won't be known to the LLM, right? You have to provide the documents of that particular company. So that document you will provide, and that you will send to the LLM actually. Not all the documents as such, parts of that. So all that we'll see. And then your query. So you give some context to the LLM, then only it will be able to generate the proper response. So that is the whole idea of RAG. So instead of relying only on the LLM's internal training data, right, you will give it some relevant information from an external knowledge source. So it may be database, vector store. So what you are giving is some context to the LLM for giving the proper response. Now the question is, how does that knowledge get into these sources, right? Like database or vector store. So how do you provide that knowledge to those sources in the first place? So that's where document loaders come into picture. They form the initial step of the pipeline responsible for importing raw documents into the system so that they can be later processed and stored. So LangChain structures this RAG workflow into 4 key stages, and for each stage it has dedicated module also in LangChain. So first phase is this data ingestion, where you do loading and splitting of the document. So it uses document loaders like PyPDFLoader or WebBaseLoader to import your data, and then uses text splitters to break it into smaller manageable chunks. So as I said, right, you don't set your whole document, whatever you are loading with, to the LLM. You actually split into smaller parts. So there are other steps. Won't go into all the details right now. We have to focus more on document loaders. So just think it like that you will split it, and then there is embedding also. So let me go through that. So that is the second phase, actually, indexing. So that's where you do embedding and storing. So when you are done with loading and splitting the documents, you have to keep them somewhere. And before storing them, you also create embeddings from that document. So there are many embedding models actually. OpenAI provides, Hugging Face provides, Google itself provides, Olam also. There are embedding models so that you will use to create embeddings, and those embeddings that will be stored in your vector store. So there are different vector databases like FAISS, Chroma, Pinecone. So you'll store your embeddings into that vector store. Now in the retrieval phase, you will retrieve the document chunks from the store based on the user's query, the most relevant one. So you do a similarity search based on the user query and get the relevant documents. So from your document which you have loaded, gone through all the stages to retrieve only those chunks which make sense for this particular query which user has asked. Then you send those chunks and this user query to the LLM to get the final answer. So LLM will use the document or data which you have sent, document chunks, and then it will form the answer for the user query using that data. So you are giving context to the LLM. So that is the whole idea. So as you can see, document loaders are the entry point here, right? So document loaders are the entry point of your whole RAG pipeline. Without them, there is no data to retrieve, embed, or generate response. So as you see, this is one important step, document loader. That's what we are going to do here. So LangChain provides these document loaders. Through that, it gives a standard interface for reading data from different sources or different file format. So you can load data from sources like Slack, Google Drive, Confluence, GitHub, and you can also load from different file formats like text file, PDF files, Word document, CSV file, even from web pages. So when you load any document, it is loaded in the form of document object, which can then be used by other components. So this document, this is also a class in LangChain actually, that you will use to store the content of your document which you are loading. So it has two main attributes. One is page underscore content, which will contain the textual content of the document, and there is also metadata. So document dot page underscore content will give you the content, document dot metadata will give you the associated metadata, which may be file name, page number. So all the document loader classes, they implement the base loader interface in LangChain. So they may have their own methods also, but through this interface, they have at least two common methods. One of them is load, which will load all the document at once. And there is also lazy underscore load. So lazily loads any document. So if you have a very large data set, then you can use lazy load to lazily load that particular document. So coming to popular document loaders in LangChain, so LangChain provides integration for more than 200 types of documents, right, or sources. So 200, more than 200 integrations are there. So of course we can't go through all of them. So we'll categorize some of these loaders and then we'll see some of the examples for some frequently used loaders. So there are file-based loader like TextLoader, which reads simple.txt file. There is PyPDFLoader to get the content of a PDF file. There is also a CSV loader, which will read a CSV file. Then you have web-based loaders. So web-based, first is WebBaseLoader itself, which uses beautiful soup package to scrape and extract text from any URL, or not only single URL, from more than one URL also you can use. There is also unstructured, which is also used to load and parse web pages. Then there is also a directory level loader, which is called DirectoryLoader. So you can load all the files from a folder. You can also specify any specific file formats, only load this kind of file or more than one file format. So it has a lot of configurations. Then there are also social platform loaders given by LangChain. So there is for Twitter, which this is the loader which will fetch the tweets of a list of Twitter users. So it uses Tweepy Python package. Then you also have for Reddit, which can fetch the text from the post of subreddits or Reddit users. Uses the praw Python package. Now coming to TextLoader. So this is the first loader we'll see. It is used to load text files, primarily used for .txt file, but it can be used for markdown files also, .md, or for code files also, like any code file, .py, .js, .java. So let's see a text loader example. So for that, actually, I have already done some pre-work. I created a separate resources folder at the project root level, where I have a genai.txt file. So you can create any txt file yourself also. So it has some text data. So that is what I'll try to read using a text loader. And I've also created a new folder, L5 document loader. Here I can create a text loader demo.py and use that. Okay, so I have to import text loader from LangChain underscore community package. So if you don't have this package, you have to install that. So you have to put it in requirements.txt. Yes, we already did for structured output. There we needed it. And OS to form the path. So rather than hard coding, we can create a path to this file. So we can first get the os.path.name, and here I can pass the file, right? For that also I can actually do like this, path.absolute path. Here I can give file. So this will give me the path to my current directory. Where my current code is running. So I'll get this directory actually, right? L5 document loader, but I need a one level up. So parent directory. So I can again use this same thing, dot path dot name, and in this directory name I can pass this. So this should give me the parent directory. I can check also into project root directory. Now I have the parent directory. From that I can then form this name which I want to load. So I have this genai.txt. So to get this I can then use again, but that I'll do in text loader itself. So text loader. So text loader, if you see right here, you can pass the file which you want to read. So what I can do here is os.path.join. Using that I can create the whole thing. So first thing is parent directory. Within that I have resources. Within that I have my file genai.txt. So I can use join method that will join them so that it is workable in all platforms, not only in Windows. So you know, right, in Windows it uses forward slash, in Unix backward slash, or I said in reverse. So whatever, so better to do it this way, and that will be my loader. This you can also actually give encoding, though in our what I'm using, at least we don't have any special character. But if you have any special characters, or you are using language which may have some special character, then you can also give encoding. I'm using a UTF-8. So now my loader is there. So I can call loader.load. That will give me all the documents. In this case, it will be, I guess, only one. Right, then you can try to see what all is there. So I can check, I said, right, number of documents. It may load it as a list of documents, right? So in PDF, generally it does. If it has more than one page, for every page it creates a separate document. So this list, I can use len to get the list. Number of documents, I want to check the content, then I can say content of document. So that will be document 0. You have to use that page underscore content. I told, right, your page underscore content to get the content. If you don't want the whole content, may use slicing to restrict it to 300 characters. Then what else I can get is metadata, right? So I can use printf metadata of document that I can get using metadata, correct? So using metadata, I can get the double quote. So document, here it is documents, document 0 dot page underscore content will give me the content of the document, metadata will give me the document metadata. And if you want to check the type is what, I can check the type of document, so which type of object it is creating. All right, so all this I can check. Then to run it, I should first go to my environment. Oops, wait. And from here I can run Python L5. That I have only one file right now. So TextLoader. All right, so it gives me, so number of document, as I said, it is very small. So only one type of documents is list. So it gives you a list of documents, and each list in that is a document object. Now I can get the content of document, which is this, and metadata. So it gives me source, which is the whole file name. So that's how I can use TextLoader. You have to import it, then this all is just to create programmatically. You reach the file name rather than hard coding it. Otherwise, it is only this line, documents equal to loader.load, then some prints to see how it looks like what we have loaded. So that is about TextLoader. Okay, so coming to another loader, which is PDFLoader. So as the name itself says, it is used to load the PDF documents. So for PDF loaders, I mean, for loading the PDFs, there are many different loaders given by LangChain. So some of them are listed here. So there is actually PyPDFLoader. So that is best for simple PDFs with mostly text. Then you have PDFLoader, which is used for PDFs with structured layouts. So if your PDF has more tables, columns, and forms, then you can use this loader. There is also PyPDF directory loader. So that is used to load multiple PDFs from a directory. There is also a PyMu PDF loader, so which is used for complex PDFs which have mixed content, right? You have images, text, multi-column text. So that kind of PDF, if you have, then you can use PyMu PDF loader. There is also unstructured PDF loader. So if you have a scanned and very unstructured kind of PDF, then you can use this one. So these are some of the PDF loaders which are there in LangChain for loading the PDF. So we'll start with a simple one, PyPDFLoader. So you, to use that, you will need installation of PyPDF package. So that is the first thing you have to do. So if we go to our code file, you have to put that in requirements.txt that you need this PyPDF for PDF loading. All right. that you have to, so let me be in my, yes, so I'm in the virtual environment. There I can run pip install -r requirements.txt so that it loads this package also, PyPDF. In the meantime, I can create a file here in L5 document loaders, PDF loader demo.py. All right, so PyPDF is installed. I have my file ready, and for that, in the resources folder itself, I have put one PDF. That is what I will try to load. So first thing, I have to get my import. So this time I'm using this PyPDFLoader from document underscore loaders in LangChain underscore community. Then I have to do the same thing to get this PDF. So rather than just hard coding it, it is better to use the logical way, programmatic way to get that file so that it works in all scenarios. So I am using this OS package for that, OS library. So I'll get from that. So first thing, I have to load the directory where my current, I have to load the current directory where my code file is, and from that I can load the parent directory. So os.path.dir_name, in that I can give os.tabs path. That I have to give the file to get the current file. That will be my where my current script is running. From that I can get the parent directory, which will be one level up. So I can get the directory for this directory. That will give me the parent directory. So if you want to check it is loading or not correctly, you can do a print project root. This much only. There I can do parent underscore directory. So why we are doing that, I've already explained that this resources, if you see, is at the same level as my project root. So I have to be here to get a load file from this resources, and what I need is this one. All right, so now I have the parent directory. So using this PyPDFLoader, I can again use the same thing to load it, os.path.join. There I can give this is already a variable, right? Parent underscore directory, in that resources. So it will join all these paths to create a path for my file. All right. This here. So now I have my PDF loader, PDF underscore loader equal to this one. Let me also do word wrap so that you can see it easily. So we are done till here, right? We have our file loaded. Rest of the things are simple. Main thing is only this much, right? You have to get your documents using this loader. So PDF loader, on that you can call the load method. So that will load the documents. Then I can print I'll just use the same thing here. So this PDF actually what I have used has 41 pages, and this PDF loader will create one document per page. So I should have 41 such documents actually. So 0 to 40 it will give a, so if I want the content of my first page, then I have to use document 0. All right, and page underscore content method is there to get the content of that particular document, and metadata to get the metadata of that particular document. Then I can load this within that PDF loader. It will take some time because it's a big document. So project root, if you see, it is getting me this name. All right, so it has loaded. So if you see, number of documents are 41, so it is creating one document per page. Type of document is list of documents. Content of document, it has given, I am only printing first 300 characters, so first 300 characters it has given. And metadata, if you see right now, you have many things with PDF. So it is giving producer, creator, modified date, source, total pages, page label, page. So page, you see with this loader, it starts from 0, but label itself is 1 in the PDF. So you will have 0 to 40 such documents actually. So if any other page you want to see, you can do like this 0, 1, 2, 3, or you can run a loop to go through all the pages. All right, so that's how you can load up PDF using PyPDFLoader. We go back to the other type of loader now. Okay, so that brings us to another loader, which is CSVLoader. So there is a CSVLoader class also in LangChain to load CSV data. So any file which contains comma separated values, that you can load using CSVLoader. So every document will contain one row of that CSV file. So as many rows are there in your file, that many documents you will get. So that's how CSV loader works. With that, let's go to the IDE to create a code for using CSV loader. Okay, here I am. So I can create a CSV loader demo.py. So all of the things are almost same. So let me get till here. So import OS, and this time what you load is a CSV loader. So from LangChain community, you can load the CSV loader. So that is one change, loaders, and then we get the project root till here, nothing changes. Then what you can do is here you want to use the CSV loader. So CSV underscore loader equal to CSV loader, where I have to give the path. So I can give using same thing, os.path.join. So that will be my parent directory. For that, I have another CSV file in the same resources folder. So this 50 underscore startups.csv, that is what I'm going to use, which has 50 rows. So I know that there are 50 rows and it should create 50 such documents. All right, so I have the CSV loader. Then I can get the documents equal to this CSV loader. On that, I'll call the same load method. So standardized interface given by LangChain. Everywhere you have load and lazy load methods. That's it. Then again, I can check. So it will load 50 rows as 50 documents, correct? So 0 to 49. Let us change this time to 4. Okay, so that is about CSV loader. That's how you can create the code. Nothing changes, only line is this one, right? CSV loader, you are loading, otherwise all the logic is same. That's the benefit of LangChain framework. It works almost similarly, so you don't have to learn new thing for every loader. Then I can run this file also. So L5, within that I have to load this CSV loader demo.py to run. Okay, so this is the output for this CSV loader. So where you get the number of documents, type of document, content of document starts here, and metadata. So it is showing row 4, so you can check here. So this row, right? So it will be 0, 1, 2, 3, 4. So this row it is showing. You can check with the numbers. 166187, which is this one, and 366168. All right, so this is the row which we are getting. So that's how you can use CSV loader to load the CSV data. Okay, then there is also loaders to load web pages. So there is a web-based loader class actually given by LangChain. Using that, you can load text from HTML web pages. So it can create document from the HTML page. So for that, you will need this package, beautiful soup 4 package will be needed to work with this web page loader. And what you have to do is with web based loader, and you give the URL from which you want to load the data, or you can give list of URLs also. So if we have to do this, then as it says you need this, so you have to go to requirements.txt, add beautiful support, and put some comment also for web page loading. I need this. Then I come here and do pip install -r requirements.txt, so it loads that beautiful support. In the meanwhile, I can create a new web page loader demo dot py. So for this, what will I need? I have to get this web-based loader from document underscore loaders. Then suppose I want to load 2 URLs. Let me get those URLs also. So suppose I have this URL and also this one. Then I can create a web loader equal to this web-based loader. In that I can pass as a list. So URL1, comma URL2. So I have my documents now. Then I can use the same thing to get all the information about the documents. So documents, okay, I have to load that also, right? That part I missed here. So documents equal to web underscore loader dot load. So that remains same. You still have to use dot load method. With that, you have all the documents loaded. Then I can run here this also python dot slash 5 from that web based loader dot py. All right, so it gets me all the required information, number of documents two for 2 URLs, type of document is listed, then some content and metadata. So source, description, so everything it gives. All right, so this is about web page loader. So let's try to create another example with web page loader where we also use LLM to ask some query about this page we have loaded, right? We have some content, so based on that we may ask some query. Okay, so to create a program where we use LLM also to generate a response or answer the query based on what we send as the document and query, what we can do is here itself I can create another one. So web load LLM dot py. So in this actually, then what will I need? And remove this OS. So I'll need all these again, template and all, because now we are creating a template, and web-based loader because we are loading a web page. So suppose first I create a load from URL where I give it a URL which is of type string, and let us create a load from URL str where I take this web-based loader and pass this URL to it. That will create a loader. Then I can get documents equal to loader dot load, and I can return this document. So this is a function which does the work of loading the these URL text from that URL. Then I can create another one, generate response, where I will send my query. So query string, I will also send this URL which I'll pass along. So URL, and it will return the response, the string. From here I'll call this function first of all, load from URL, and pass this URL. That will give me the documents. Now I can create other things here itself. So I can take model. So I just created. So I'm using Gemma 4 from chat Google Generative AI. So that will be my model, and then of course I have to create a system underscore message from system message where I can say content equal to you are a helpful assistant which answers question based on the given context. So I'm telling it explicitly that it has to use the context provided here based on the given context. Then just to put emphasis on that, you can say nothing else. So it has to use the provided context only to answer the question. Then I can also create a human message which will be from human message prompt template this time. From underscore template use here. Here I can give my query. So maybe I can write context and I can give context. All right. And query, right? We can give some space here. So query will be this query. So this is my human message. Then I can create my prompt equal to chat prompt template where I can pass these both. So system message, human message. The prompt also, model also, I am using parser also. So parser equal to str output parser. Now I have all the things. So chain I can create using prompt, then this model, and then I have this parser. So my chain is also there, which I can then invoke response equal to chain dot invoke. That's where I'll pass both the things as a dictionary. What are those two things? My query and context. So first thing is query. That's what I've given here, right? Query. So query will be what is sent here. So that also is query. So query, and another thing is here itself context, right? I'm giving context. So that will be my document, right? What I'm getting here. So document dot page content. So content of that document. So that will be the response. Then I can return that response. All right. Then I can call it like this. If name equal to main, let me get a URL. So if I pass this URL, let's say, then I ask a question also. What is the main topic of the article and what are the key points discussed? So this is my query. All right. So that's what I'm doing here. I load the document. So this part is for loading, created separate function. So it is easy to understand, and that's how you should work also. Then we have document and model and all this, then prompt, query, context. So here you have to tell explicitly how LLM should behave. So it has to answer the question based on the given context only, nothing else. So I'm making it very explicit how I want the response to be generated by LLM using which context, right? And then I give my query. So looks fine now. Let's try to run it. So web load LLM. Okay, here itself I have, okay, I gave only one equal. Okay, so I have to send two things, right? I forgot to add this URL to it. So I have query and URL also, sorry. Yes. All right, so response is, main topic of the article is how to create a simple retrieval augmented generation application using the LangChain framework. So URL itself says that it is about, LLM won't infer it from URL itself, it will go through the content. I'm just giving you a heads up that this URL itself tells that this is about RAG application. So then it goes through how you can create a RAG, that summarizing the steps in that. It is telling about the programs also, what all code files are there. All right, so that is just one example how you will actually use these documents after loading. So this is like a precursor to how to create a RAG. This program itself tells you. because you are using your own context to answer the question. So, all right, that is about the web-based loader, where you can use web-based loader to load pages from the web. So, another loader is directory loader, which is used to load all documents from a given directory. So, all the documents it will load from the given directory. You can give the format for the files which you want to load from that directory. So there are some parameters which you can pass while creating object of this directory loader class in LangChain. So first thing is path. So you can give the path. So that path will be of the directory from where you want to load all the files. Using glob, you can give the pattern. So it will filter the files which match that pattern. So only those files will be loaded. Like this you can give, right? Asterisk slash asterisk.pdf. So it will load all the PDFs from this directory as well as all the subdirectories. Then you can give loader underscore CLS, which means loader class. So if it is PDF, suppose, then you can say, okay, loader class will be PyPDFLoader. If you are loading .txt file, then you can say, okay, loader class will be TextLoader. So that you can specify with loader underscore CLS. Then you also have use underscore multi-threading, which if set to true means that it will use multiple threads to load those files. So it will speed up the process. Silent underscore errors is also there, which when true means it won't throw an exception if one of the file which it is trying to read fails. It will skip that particular file rather than raising an exception. So these are the parameters which you can use with directory loader. Then let's try to create a program to see how it works. So here itself I'll create, so I can add a file directory loader demo.py. So this is the directory loader class which you will import from document underscore loaders. And if I'm trying to get all the PDFs from a specific directory, then I have to give for loader class, right? PyPDFLoader. Then I can create a loader equal to directory loader. Here, first thing I have to give path. That will be, so it is in resources folder in LangChain proj. So I can create it like this, right? LangChain proj slash resources. So this is the directory from which I want to load all the files. Then I can give glob equal to strict slash strict.pdf. So it will load all the PDFs. Then I have to give loader class also. So for that I can give loader underscore CLS equals that will be this PyPDFLoader. So my loader is loaded, then I can use documents equal to loader dot, again method is same, load method, and I have all the documents. So if I want to print, let's print only the number of documents. Number of documents, then documents. So if you see resources as two PDF folder, and in PyPDF when we were doing, I loaded this one which had 41 pages when we displayed the result. So 41, and now there are two, so pages should increase. So length of the document list, because for each page it will create a new document. That way we can check. So Python slash L5 within that I want to run this directory loader demo. There is some warning p.14. Okay, sorry. I haven't gone into my virtual environment. Okay, so there is an error that directory not found. So I think it will go till here, so I don't need to give this part. So I can give only till here. /resources. You can also check with the import os print os dot get current working directory. So what is the current directory? We have to add after that only, right? Okay, this is also wrong here. It should not be double quotes. This is a loader. Let's try with this part now with these changes. So we have removed this path. We have removed that root, and here we have removed double quotes. Okay, yeah, since it is still here, so we have to give only after that. Okay, so if you see now, number of documents is 47, so it has added 6 more, so that means it is reading both the PDFs or loading both the PDFs and reading all the pages of those PDFs. That is why number of documents have increased. So that's about directory loader, and that also finishes what we had to do about this document loader. So we have gone through some of the loaders like text loader, CSV loader, PDF loader. Within that, PyPDF loader, web-based loader. There we also tried to use it with the LLM to query based on the context given, and this directory loader. So that's all for how you use document loaders, which is one of the main building block of creating RAG workflows. Thanks for watching the video. Please don't forget to like and subscribe.